Hello students, let's have fun with the factorials. Do you really know about these factorials? Let's talk about some types of factorials in this video. You are already familiar with the factorial, which is represented by n factorial, and its value is the product of first n natural numbers, n, n minus 1, n minus 2, n minus 3, so on up to 3 into 2 into 1. For example, if we have to solve 5 factorial, its value is 5 times 4 times 3 times 2 times 1, right? So when you calculate it, you will get 120 as the value of the 5 factorial. What about next type of factorial, which is double factorial? It is represented by n double factorial. What is the value? How to calculate it? Its value is, you have a number n, right? So subtract 2 from it and take the product every time, n, n minus 2, n minus 4 and so on. It will end up either with the 2 or 1 depending on the value of n is even or odd. For example, let's calculate the 5 double factorial. So 5 double factorial will be 5 times subtract 2 from it, which is 3, subtract 2 from it, which is 1. So it is 15. So 5 double factorial is 15. Now let's talk about the 6 double factorial. 6 double factorial means you have to take 6, then 4, then 2, which comes out as 48 at the end. So this is your double factorial, right? So let me tell you one thing. N double factorial is not same as taking the factorial of n factorial. No. See, for example, 5 factorial, we have already seen that its value is 15. What about 5 factorial? It is 5 factorial is 120. So taking the 1 factorial of 120, no, these two are different things. So always keep in mind that these two are different things. Okay, let's talk about the triple factorial. In the same way, it is represented by n triple factorial, and its value will be equal to what? Yes, you are right, that you have to subtract 3 this time. So its value will be n, n minus 3, n minus 6 and so on. For example, let's say we have to calculate the 5 triple factorial. So its value will be 5, then subtract 3 from it, which is 2. That's it. So its value will be 10. And in this way you can calculate the triple factorial or multifactorials also. I hope you get this idea for the multifactorial by looking at the factorial, double factorial, triple factorial and so on. So you can take multifactorials in that same way. Okay, let's talk about the fifth part, which is subfactorial. What is that? It is represented by factorial of n. Like this. It is actually the derangement of n objects. It means you have n objects and you have to place those n objects in n places so that none of the object is at its correct position. That is called derangement also. Its formula is n factorial times this, which is 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial, alternatively plus minus signs and so on. For example, let's calculate factorial 5. It means you have 5 objects or 5 letters and you want to arrange them in 5 envelopes so that none of the letter goes to correct envelope. So how many ways are there for the derangement? The answer will be 5 factorial 120, 1 minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial minus 1 upon 5 factorial. When I solve it, I will end up getting the factorial 5, or you can say subfactorial of 5 is 44. That's the answer. Okay, so let's talk about the next type of factorial, which is primorial. Primorial is represented by n, this hash, and its value is given by product of all the primes which are less than or equal to that number. For example, if I calculate 5 factorial, so take the product of those primes which are less than or equal to 5. So what are the prime numbers that you know? 5, yes, it is there. Then take the 3, then 2. Yes, it is the value of primorial of n, and its value comes out as 30, right? In this way you can calculate the primorial for any number. So take the product of all the prime numbers which are less than or equal to that number n. For example, 8 factorial, if you calculate, you will end up getting 7 times, then 5, then 3, then 2, right? In this way you will get the answer as 210. Next type of factorial is superfactorial. Superfactorial given by Sloane, it is represented by SFN. Okay, superfactorial n. Now its value is given by product of all the factorials, right, starting from k equal to 1 to that number n. For example, you have to calculate superfactorial of 5. So the superfactorial of 5 for this question will be given by 5 factorial, then take product with the 4 factorial, then take product with the 3 factorial, then take product with the 2 factorial, then take product with the 1 factorial. When we calculate this, we will end up getting 34560 as our required value for this, right? Okay. Next type of factorial is super factorial by pickover. It is represented by $n and its value is given by this. How to calculate it? Let's take an example. For example, if you have to calculate the super factorial for 5, its value will be 5 factorial like this, and we know that 5 factorial is 120, right? So take 120 and its power 120 and its power 120 and its power 120 and so on like this. How many times? 120 times you have to do this. Okay, it's a very large number, so I'm not going to calculate this value, but you have to take 120 raised to the power 120 raised to the power 120. That is the meaning of this super factorial, which is represented by $5. Next type of factorial is exponential factorial. It is represented by $n again, but its value is n raised to the power n minus 1 raised to the power n minus 2 raised to the power so on. We have to reduce one power every time. So for example, if I have to calculate $4, right, exponential factorial for 4, its value will be 4 raised to the power 3 raised to the power 2 raised to the power 1 like this. And when we calculate this value, it comes out as 262144, right? So that is the value. That's how we calculate exponential factorials. Next type of factorial is hyperfactorial. Hyperfactorials are represented by Hn and its value is given by n raised to the power n, n minus 1 raised to the power n minus 1, n minus 2 raised to the power n minus 2, right? Means you have to take that number n, decrease 1 every time, take the product, but the every number must have the same power. So for example, if I have to calculate 5, hyperfactorial of 5, right? So that will be 5 raised to the 5 multiplied by 4 raised to the power 4 multiplied by 3 raised to the power 3 multiplied by 2 raised to the power 2 multiplied by 1 raised to the power 1. And its value comes out as this, 86,400,000. Okay. That's it for this lesson, and I hope you learned a lot from this. If you need one-on-one session, group session, or you need help in the homework, doubt clearing session, or you have any assignment or project, you can contact us. Or if you have any other question, you can write down your question in the comment box. Thank you for watching this. See you in the next part. Keep watching, keep learning.